Hello, Luke. Welcome to lesson 47. So today we're going to be talking about percents. And in particular, we're going to be talking about percents that are less than or greater than 100. So to begin with, I think the best place to start would be to just ask you, what is a percent? What would you say if I were to ask you that? What is a percent? And then we can start talking about percents less than or greater than 100. Well, the answer is pretty simple, and it's very much a review from previous years. So hopefully this is very easy for you. But just to make sure that you recall what a percent is, let's talk about the word itself. So if we look at the word, we can break it up into two syllables. There's per, and then there's cent, right? Well, cent is just the Latin word that means 100. Think of, 100 cents in a dollar, or 100 years in a century, right? Or 100 centimeters in a meter, right? So whenever we hear that word cent, we should automatically think, oh, 100, okay? And then per, well, that we use, in the English language. I might say that there are, 10 pretzels per bag. Okay, so that means for every one bag, there are 10 pretzels. Well, in this case, we're just saying per 100, or you might even say for every 100. Okay, so that's what a very literal a very literal meaning of the word percent is, for every 100. So if I were to say something like, I have 30% of something, what would that mean? Well, if we think about what we just talked about, that would mean 30 per every 100. Okay, so 30 per every 100. So for every 100, we get 30 of something. All right, that's what that should mean, or that's what that does mean. Now, another way to think of that, and hopefully maybe you've already realized this, that 30 per every 100 should really remind us of a previous class in which we talked about ratios, right? We talked about ratios that looked like this: 30 to 100. 30 to 100, meaning there were 30 of something for every 100 of something else. Well, that's kind of what we're saying here, 30 per every 100. Okay, and if you recall when we talked about ratios, we can write this as a fraction. So it's 30 over 100. That is what 30% is. It's 30 over 100. And hopefully you recall this from previous years. This is very elementary right here. So 30% would stand for 30 over 100. Now, once we have it as a fraction, it's very simple to convert this into a decimal by recalling that if we have a number, the number 1, followed by any number of zeros you want, it's very easy to multiply or divide numbers by, a 1 followed by a bunch of zeros. Okay, and the way we do it is simply by adding up the number of zeros and moving the decimal place that many times. If we are multiplying by one of these numbers, we would simply move the decimal place to the right, that the corresponding number of zeros. All right, so for example, if I'm taking 28 and I'm multiplying it by 10, all I need to do is find that decimal point, which would be here, and I'm moving it one place to the right, which would then turn this into a 280, right? So 28 times 10 is 280. Very, very simple. If I have, 3,000 and I want to divide it by 1,000, well, 1,000 has 3 zeros. So find the decimal here. Maybe I'll do this in a different color. We find the decimal, and we simply move it 3 times, in this case, to the left, because we're dividing, so the number is getting smaller, which means we have to move that decimal to the left 3 positions, because we have 3 zeros. So we'd end up with a decimal point right here, which 3.000 is equivalent to just 3. Okay? All right, so remember, whenever we're multiplying or dividing numbers that start with a 1 and end with a bunch of zeros, all we're doing is moving that decimal place a corresponding number of times to the number of zeros that we have in this number. Okay, very good. So that should make this part very simple. 30 divided by 100, we're dividing it by a 1 with 2 zeros, so we need to move this decimal point twice to the left because we're dividing. There's once and there's twice. So we end up with 0.30, which we could also write as simply 0.3. The 0 at the end of a decimal doesn't mean anything. So we have 0.3 would be the decimal equivalent to 30%. All right, so this is all straightforward review. So where am I going with this? Well, we are going to start to use some of these things in story problems. So let's move on and let's try a story problem. All right, so let's say I have something very simple. Let's take what is 30% of 90, and maybe I'll clarify this a little bit. What number is 30% of 90? Now, this shouldn't look too intimidating to you because you've done many problems like this. You've done fractional problems like this. There have been many times where you've had something that said, you know, what number is 1/2 of 90, right? This one you've done many times. Other times you might have had decimals. So you might have something that looks like this. What decimal, well, actually, no. Well, what number again? What number is, we might say, 0.5 of 90. Whoops, not 90%. I've got percents in my head right now. What number is 0.5 of 90? All right, or 5/10 of 90. Both of these you've solved before many times. And if you recall, I told you to think about the unknown, the what number, as a WN to represent what number. The is always equals. Then we have the 1/2. And remember, I've always told you of almost always means multiplication in story problems. So we have 1/2 of 90. It's 1/2 times 90. And now we simply solve for the WN by taking 1/2 times 90, which we would find is 45. And that would be the solution to what that number is. All right. And then the same thing applies here. It's just as a decimal. So here we would have what number is 0.5 times 90. And again, we're going to end up with 45. Okay, so these two story problems should look very familiar to you. You've done many of them throughout the previous lessons. Today, the only difference here really is that we are substituting in for the fraction or the decimal a percentage. That's really the only difference. So what number is 30% of 90? Well, it's the same sort of scenario here. We're going to take the what number is going to be a WN. The is going to be the equals. And then we have this 30. And this is where we have to figure out what we're going to do with this 30. Now, there are two things that you could do here. To be honest, I really don't care which one you do. You can even do one time and do a different one a different time. But you need to convert this 30% into something. We just can't leave it as 30%. That's not really computable. So we need to write that as either a decimal or a fraction. You can decide which one you want to do. As a decimal, we have to, well, let's start with a fraction. As a fraction, remember what we just talked about. Whenever we have percent, it just means this 30 or whatever this number is over 100. So that's what it would be as a percent. As a decimal, all we need to remember is to, for any percentage, just move the decimal point over 2 places because we're always dividing by 100, which has 2 zeros. So all we have to do is picture the decimal point here, move it over twice, and that would be our decimal. So we have 0.3 as the decimal. Now, which one of these you would like to use in your equation is totally up to you, whichever one you feel would be less work for you. All right, but both of them are totally legitimate and legal. So 30 over 100, let's just go with, let's go with the 30 over 100. We'll go the fraction. So we have 30 over 100. So we have what number is, which would be equals 30%, which is equivalent to 30 over 100, of, which means multiplies, and 90. All right, so here we have our equation. It's pretty straightforward for us. So if we multiply this out, we're going to have 30 times 90 is 270, right? Over what's 100 times 1. And I could have cross-canceled here, actually. I could have, crossed out, 10 here and 10 here. But I'm going to leave it the way it is. 100 times 1 is 100. Now I can turn this into, divide this out or turn it into a decimal. Okay, so if I divide 270 by 100, again, all I'm going to be doing is moving that decimal point twice. So we have once, twice, you're going to end up with 2.7. All right, so 2.7 wait a minute, something's not right. Oh, this is 2700. Oh. So if we put that percentage in, we'll have the 30 over 100. And then we have of, which means multiply. And then we have 90 over 1 in this case. So we have 30 over 100 times 90 over 1. 30 times 90, well, that's going to be 2,700 over 100. Now, I could have also cross-canceled this. Looking back at it here, I could have done that very easily. I could have divided both the numerator and the denominator by 10. But that's all right. We'll leave it the way it is. So 27 over 100, we now are dividing by 100, which means we just have to move this decimal point 2 times to the left, and that's going to give us 27. So 27 is 30% of 90. All right? So very straightforward, not complicated. Just have to remember to convert that percentage into either a fraction or a decimal, both of which you've already used in previous problems. So very straightforward. That being said, some of these percentages, they're going to try to be a little tricky. So we're going to develop kind of a method to solve these percentages. And I want you to pay close attention to that because I'll be looking for it in your seat work. So let's move on and try some. So here is a story problem. 20% of what number is 25? Now, this is the rub. After it says, work the problem and then draw a diagram of the problem. Now you might be saying, Jim, why do I have to draw a diagram? I know I can figure this out, just like we did the previous one. Well, I have my reasons. The book has its reasons. The book is actually the one that really emphasizes this diagram step to solving these problems. And I do think it's a good thing and it's worthwhile doing. So I want you to draw the diagram. All right, even though it may seem tedious right now. Later on, these problems are going to take a little bit more of a difficult turn, and that diagram will be very helpful in solving those problems. So let's get used to it now. So make sure you don't just give me the answer here. I also want to see in your seat work the diagram of the problem. All right, so now that I've scared you to death, knowing that you have to draw diagrams, let's look at this and actually find out what the diagram looks like. All right. So the first step is simply to work the problem. That's going to be the part that's pretty familiar to us. So we have 20%. All right. Now, again, we have to convert that into a decimal or into a fraction. So in this case, I'll go as a decimal just because I didn't last time. So 20% as a decimal is going to be 0.20, right? Because if I take 20% and if I turn that into a decimal, all I need to do is move the decimal point twice to the left, right? That's always the steps that I'll take to convert a percentage to a decimal. Always just move the decimal twice to the left. All right. Now I could write this as 0.2 because that 0 doesn't count, but just to emphasize that this is the 20%, I'm going to leave it like this for right now. So 0.20 of what number? So of means multiply. What number? That's the unknown. What number indeed? And then we have is, which is our equals, and 25. So this is our equation for the problem. Let's go ahead and solve it now. So what steps do I need to take? Well, this should be all very much review, but we need to get rid of the point 20 near the what number. So it's being multiplied by the what number, so we'll divide it by the what number, right? These will cross out, and we get what number is equal to 25 divided, let me put this over somewhere else. 25 divided by 0.20, all right? So here we have to remember how to divide when we have a decimal point in the quotient. So recall that there is an invisible decimal here. We start by moving this over twice to get rid of the decimal in the quotient. But if we do that, we have to move it over twice here as well. So we have to tag on 2 zeros to the end of this number. Okay? So now the decimal points are at the ends of both numbers, which means they're invisible. So now we can divide this out. 20 can go into 25 once, into 50 twice, and then into, bring down another 0, 100 5 times, which is going to work out really nicely. So we have 125 is the what number? Okay? So 20% of 125 is 25. All right, so that's working the problem. Now comes the fun part. We need to draw the diagram. Okay, so to draw the diagram, there's always two components to the diagram. And I think maybe in your notebook, you should be making some notes on this so that you recall how to draw the diagram. Okay, so the first step, the first component to the diagram, there is and maybe we'll do this in a different color for the fun of it. There is a before component to the diagram, and there is an after component to the diagram. And we will draw basically a bubble right above the before, and we'll draw a bubble right above the after. Okay? Now, the before, what that stands for, what that means is what was the original amount? Before we did anything to it, what did I have at the very beginning? Okay? What was the original? Now, the way to think about this is, what was the 100%? Okay? The 100%, meaning at the very beginning we had 100% of something. What was it? Okay? In this case, if you read the problem, 20% of what number is 25? Now, you really have to think about this. 20% of what number is 25? So I'm looking for what we had originally. Okay? I'm taking something, some original amount, and then I'm taking 20% of it to get to the 25. So the 25 is not the original amount. That's how much we're kind of taking away from the original amount, 25. Okay? The 20% is obviously just a percent. That's not an original amount. So the original amount is the what number? That is the original amount. Okay? So the original amount, the before, is the what number? That was the variable. Now, we've already solved the problem, and we know that the what number is 25. So I'm going to put in here what number, and it's going to be equal to 125. Okay? What number is equal to 125? Sometimes what might help with this, and I think they actually put this in the book, is look for the of. Okay, that's kind of helpful with these percentage problems. The percent is always going to be a percent of something. So it's that something that's the original amount. So look for the of, and what comes right after that is usually the number that's going to go into this bubble, the before bubble. All right. Then we have the after bubble. Now this is the 100% in the before. The after bubble is the less than 100%. All right, so the whole bubble will still comprise 100%, and that's why we roughly draw the bubbles the same size. But in the after bubble, we're actually cutting up this 100% into a couple of pieces. All right. So what are the pieces that we're cutting it up into? Well, we're cutting it up into 20%. So on one side of this bubble, we're going to have the 20%. So I'll put that right here. We'll put that up on top. Okay. Now, that's the only percentage that they gave us. However, to complete this bubble, I need to decide what's the other portion of this bubble. If this is 20% of the bubble, what portion of the bubble is this on the other side here? Well, remember, the whole bubble has to add up to 100%. 100% means everything, right? It means the whole kit and caboodle. We're taking everything. So this whole bubble has to be 100% in total. So here we have 20%. So below that, the other portion of the bubble must be 80%, because 20% and 80% add up to 100%. Okay? They didn't tell us that up here, but it's very clear that we can discern that on our own. All right? So we have 20% on top, we have 80% on the bottom, and now we can say, well, what do we know about the 20% in terms of a number? Okay? These are percentages. What's the number that is 20%? Well, the number in this case is 25. 25 is 20%. Remember, that's what this whole problem is saying. 20% of what number is 25? So we're saying 20% of this number is 25. So 20% equals 25. All right. So this bubble, you might kind of think of it as the of bubble. Okay. Like I said earlier, look for that of. This bubble, you can kind of think of it as the equal bubble. Look for that equal sign. Okay. So here we have the is. The is means equal. So equals 25. So that's the 20% equals 25. Make sure you put that 25 in the right spot. It's not down here with the 80. We didn't say 80% equals 25. We said 20%. 20% is 25. Okay? So, but that, to complete the bubble here, we can actually compute this number for the 80. Because if 20% was 25, well, then what's 80%? Well, remember, the whole bubble has to include everything, and everything is 125. So if we've already used 25 of that 125, and everything has to be in the bubble, well, then 100 of it has to be down here, right? Because 100 plus 25 is 125. So 25 is 20% of 125, and 100 is 80% of 125. So that is the complete picture of our diagram. Okay? They may seem kind of complicated at first, but you'll need to practice them. So in your notebook, you should write down how to get to this diagram. Okay? Just draw an example diagram, show how it's laid out. Make sure you always write the before in the 100%, write the after. Literally, what you see in this orange box is what I want to see in the work that you do in your assignments. Okay, so make sure that you know how to do that. Write it down in the notebook and refer to it when you're doing your problems for your assignment today and in future days as well. All right, so let's continue here. Let's try another one and see if these can get any trickier. So the next problem, what percent of 65 is 26? All right, so that's, and then we have to work the problem, draw the diagram again. So let's first work the problem. What percent? Now this is interesting because it's not what number in this case, it's what percent. So I'm going to write that as a WP representing what percent. And then we have our of 65 is equals 26. Now here we have to be careful, all right? Watch out. They're asking for what percent, which is very different than asking what number, because a percent is not the same thing as a number per se, specifically. So when we have the variable what percent, we're always going to want to write it over 100 because remember that's what a percent is. Okay? If we were to just replace this with, take your pick on a percentage. Let's say it was, 25 percent. Let's just put that in here. Well, think about what that would mean. If this was the what percent, 25%. Well, remember, 25% means 25 over 100, right? That's what that percent means. So here we can't just write a variable. We have to remember that that variable has to be a percentage. So the easiest way to do that is just right away at the beginning of the problem, put it over a 100 to remind you that this is a percent. All right. Now, technically, I suppose you could solve this for a WP without putting it over 100 and then put the answer over 100 to turn it into a percent. That would be fine too. But I think it's good to do it at the beginning just so that you remember what we're dealing with here. We're dealing with percents, so let's put it over 100. Okay? So, knowing that, let's move on. So, we are now wanting to get WP all by itself. So, WP, times 65 over 100. We can kind of rewrite that if you want, just so that you're maybe a little more clear on how I'm going to do this. WP times, 65 over 1, well, that's 65 WP over 100 equals 26, right? So we'll start by multiplying both sides by 100 just to get rid of the denominator, right? So if I multiply this, the denominators will disappear, and I'm left with 65 WP equals 26 times 100. Well, this is a multiplication problem with involving a number with a 1 and some zeros. So we need to just move the decimal point to the right this time, 2 places, because there are 2 zeros. So 1 place, 2 place, that's going to be 2600. Okay. Then we can divide this out. So we end up with 2600 divided by 65. So if we do that, what's going to happen here? Well, 65, what's this going to be? 20, 26, 0, 0. So it's going to be 40. So this will cross out, and we end up with WP equals 40. And that's a percentage. What percent? So the what percent is 40. So it's good to write that as a percent. 40%. All right. So going back to the problem, we're saying 40%, and maybe we'll get rid of this so we don't get confused, because this was just an example. And now I've erased some of my writing, but I think we know what that it says. What percent? So we're saying 40% of 65 is 26. All right. Now let's draw the diagram. So to do that, maybe we'll start with a magenta color here. So what percent, diagram. Let's do we got the before bubble, right? Before, or the 100% bubble, includes everything. And then we've got our, different size. Let's, these don't have to be perfect, but it is kind of nice to get them close to the same size here. Pardon my drawing. And then we have, this is our after bubble. All right, so what do we have before? Remember, we're looking for the of, if that helps you. So what do we have for the of? Well, here's the of. It's of 65. So this bubble, the whole thing is 65. So we're dealing with a quantity of 65, and we're breaking it up into parts. This is the before. This is what we start with. And then we break that up into parts. And the first part is going to be this 40%, right? We definitely want that as a part. Which then would mean, what's this part? If this is 40%, what's this part? 60%, right? Because they have to add up to 100. All right, so what is 40%? Well, the 40%, what did they say? This what percent, which is 40%, is 26. So 40% is 26. So if 40% is 26, what's 60%? Well, we could just take this 65 and subtract this 26 to find out what's left over for that lower bubble, right? Which is going to give us, 39? So we have a 39 as our 60%. And this is our complete bubble. Okay? All right, let's move on. 30% of 300 is what number? All right, so once again, why don't you try to do this one on your own, and then we'll do it together. All right, so let's see how you did. Let's begin with the problem. 30% of 300. So we have 30%. I'm going to write that as a decimal. Well, let's go with it as a fraction this time. 30 over 100. Of, meaning multiplied by 300, is equals what number? What number indeed? Now we can solve this. We can do a little cross-canceling here this time maybe. Right? And we end up with 30 times 3, which is going to be 90. That's our what number? Very simple. All right. Now let's draw that wonderful diagram. So we've got our first a bubble, our before a bubble, or 100% bubble. And then we've got our divided bubble, or our after bubble. Okay, and what do we have as our before? Remember, we're looking for the of. So here's the of 300. And just, it's nice to at least mentally make sure that this makes sense. 30% of 300 is what number? So we are taking 300, that's our original number, and then we're pulling out of that 30% of it. So 300 is definitely the original number. And then over here, we're taking that 300 and we're cutting it up into two groups. The first group is going to have a 90 in it. That's what we know. And that 90 we know is 30%. We figured that out. So 90 is equal to 30%. So down on this lower end, we have to figure this out. So this is 30%. Down here, we're going to have a 70%, right? Because 30 plus 70 has to would equal 100. And then 90 plus something has to be 300. Well, that's an easy one. 90 plus 210 would have to be 300. That's the total. We're using everything. So that is our diagram. Just like that. Excellent. All right, now we're moving on to our second leg here of the journey. We're going to be talking about percents greater than 100. Everything else that we've been dealing with have been percents less than 100, 30%, 25%, and whatnot. What happens if we have a percentage that's greater than 100%? Well, that's an interesting thought. Let's take this story problem and give that a whirl. So, what number is 120% of 60? Now, you might look at that and go, whoa, 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 it's 120%. I thought 100% was everything. How can I have 120? Well, let's not think about that right now. Let's just solve it the way it's written. So, what number would be Wn is equals 120%. Now, how am I going to convert that into a fraction or a decimal? We're just going to convert it into a fraction by putting it over 100, just like we did with the last ones. All right, and then we have of, which means multiply, and we have multiplied by 60. So there's our equation. Not bad at all. We can actually cross-cancel a little bit here. These zeros could go away, right? And we have 120 times 6. And what's that going to be? 720. And then that's all over 10. Which is nice because then these will cross out and we are left with 72. So 72, if I just replace that up here for the what number, 72 is 120% of 60. Now stop and think about that for a second. 72 is 120% of 60. So what did we start with? We started with the 60. Remember, that's the number that's after the of. That's our before in our before bubble. We started with 60, and we took 120% of it, and we ended up with 72. So we actually ended up with more than what we started with, which should make sense to you because we used more than 100%. We took not only all of the 60, the 100% of the 60, but we also took another 20% more. So that's why we end up with a larger number in the end. So the 60 actually grew to a 72 by taking 120% of it. Okay? So what's our diagram going to look like here? Well, let's do it. So we have our before. Nothing really changes with our before bubble. It's still the before, and it still means the 100%. Okay? So, and this actually, hopefully it clarifies why I keep writing 100% here. That 100% is the full amount that we start with. And what is the full amount that we start with here? Well, we're talking about that. We started with the 60. That was the 100%, the 60. The 72 became the 120%. So 60 is what we started with. Be careful. It's not 72, even though if we look at these other problems, we started with a large number, and then inside our other bubble, we had numbers that were smaller than our larger number because we were cutting that down into two different groups. All right. Here, though, because things are kind of topsy-turvy, we're actually growing the number. We're not cutting it into groups. This first number is not the largest number that you see up there, so be careful. Okay? It's 60. That's what we start with. Now, this second bubble is the after bubble. Now, this one is where we get to have a little fun here because what happens? Well, we don't have the same amount, right? In these other bubbles, whoops, wrong direction. In these other bubbles, this circle was supposed to be anyway the same size as this circle. They both contained the same number. 300 here, 300 here. It was just divided up between two things, but it was still 300 total. So this quantity in this circle was equal to this quantity in this circle. But over here, because things grew, we no longer have the same size circles. So to kind of demonstrate that, we're going to kind of show a circle that's kind of grown in size. So we'll kind of start with a circle like this, and then we'll kind of say, whoop, nope, it kind of bubbled out into a larger circle. All right. Now, this doesn't mean that it's twice the size of 60, even though the diagram seems to indicate that. The diagram is not to scale. All this would indicate is that we're growing this 60. We started with kind of a 60 size bubble, but then we added on to it. Okay, so this would indicate growth. So what was the growth? Well, here we only have, before we divided this up into two sections, here we only have one section. We have the 120% because that includes all of this 60 plus an additional 20%. So 120% is equal to our 72. Okay, so hopefully that kind of makes sense. I suppose if we wanted to be consistent here, before I was writing my percentages second, you can do it either way, but maybe just keeping consistent. This would be 120% over here. This is 72 over here. So 72 is equal to 120%. All right, so if that doesn't make sense, pause the video. Maybe rewatch this last couple of minutes here, or just think about it for a second. Make sure that that's clear in your head. And again, in your notebook, write down how to draw the diagram if we're dealing with percentages that are greater than 100. Okay? Very good. Okay, so let's go on to this problem and try this one out. So here we have a little bit of a different scenario. If 200 is increased by 175%, what is the result? Interesting. So think about what's happening here. If 200 is increased by 175%, so what are we doing here? We're taking 175% of the 200. No, that's not what we're doing. All right, so let's try this one. This one is probably as complicated as it's going to get for you, so really pay attention to this one. If 200 is increased by 175%, what is the result? All right, so let's stop and think about that for a second. 200 is increased by 175%. This one might make a little bit more sense to draw the diagram first, which is interesting. So the diagram, let's start with our before diagram. Here's our before. So what do we start with here? Well, we're starting with 200. Now, I know this is a little odd because I told you before, look for the of, and that'll kind of reveal to you what's the before, the 100% bubble. Okay, but in this case, there isn't an of. Did you notice that? If 200 is increased by 175, what is the result? There isn't any of in the story problem, so that may complicate things for you a little bit. So then you have to use your head. What is the beginning? What is the 100%, the number that we're starting with? And if you think about it, it's 200, right? We're taking 200, we're increasing it by 175% to get some result. So we're starting with 200. So the 100% is going to be the 200, okay? Now we're increasing this. So when we see that word increase, we know that things are growing. So we started at 200 and we're growing it, which means that our after bubble is going to be our double bubble. Okay, because we're growing it. Okay, so what are we growing it by? Now, this is the pitfall. Watch out. Think about what they're saying here. 200 is increased by 175. So if it's being increased by 175, what does that mean? Well, we're starting at 100%. 200 is the 100%. And they didn't say it was increased by 175 as in the number 175. They said it's increased by the percentage of 175. So don't just think you can take 200 and add to it 175 and go, there, I've increased it by 175. Well, yes, you've increased it by 175 numbers, you know, the number of 175, but you have not increased it by 175%. That's very different, okay? So what we need to do is not increase the 200, not add 175 to 200, but we need to add 175 to the percentage that represents 200. So 200 is our original full amount. That's our 100%. So we are increasing this 100% by 175%. Okay? So I'm increasing it by 175%. So what's this after bubble percentage? This after bubble percentage now is going to be 275% of the original number. Are you following me here? We took the original 100%, we increased it by 175%. Ooh, sorry about that. That was annoying. We increased it by 175%, which means then we've now got a grand total, after all is said and done, of 275% of the original number. Well, this 275, the second bubble here, percentage, is always of the first bubble. So it's 275% of the 200. Well, 275%. Whoops. 275% of 200. We know how to work that mathematically. It's multiplication, right? And this is going to equal some results, which is what they're looking for here. What is the result? So 275% of 200 is going to equal the result. We need to just multiply this. Let's take that 275 and convert it into a fraction. Of means multiply. Then we have 200 over 1. These can cross cancel, right? And you're going to end up with just a 2. So you have 275 times 2, which is 550. So 550 is equal to the result. That is our solution. That is the result. So we have now grown our 275% to a new number of 550. Okay? That is as complicated as it is going to get, and it's not too bad. The thing you have to remember is that this percentage, when they say it's being increased, the original amount is being increased by a certain percentage. We need to remember that this percentage is being added to the percentage of the original, and the percentage of the original is always 100%. So we're actually now at 275%. All right? Okay, if that didn't make sense, rewind. Watch that again until it does, okay? Excellent. All right, let's try this one. So what percent of 30 is 90? All right, so let's work it the way we've worked all of these. Just parse it out here. What percent would be WP? But now again, remember, it's a percent, so we have to write that WP as being over 100. All right, so what percent of 30 times 30 is 90 equals 90. All right, so now it's just an equation that needs to be solved. So if we kind of do the multiplying out here, just to kind of make it a little more straightforward, 30 WP over 100, right? That's what that would give us on the left side, equals 90. We can now multiply both sides by 100. I'm just going to do that in my head. That's going to be a 30 WP on the one side, 90 times 100 on the other. That's going to be 90 with two more zeros, 9,000. Now we can divide both sides by 30. So we end up with WP. And of course, the zeros cross out. That's easy enough. And then 900 divided by 3 is going to be 300. So the what percent is going to be 300%. Okay? Now to draw the diagram. And here we know we've got our before bubble. That's straightforward. So what did we start with? What was the original 100%? Well, the original was what percent of 30? Here's our of 30. 30 was the original number, okay? And then we took that 30, and what did we do to it? We got it up to a 90. We went from a 30 to a 90. So that means we grew it. And the obvious indication of that is we have our what percent right here, and it's 300, okay? It's actually a lot bigger than 100%. So we definitely grew it. We went way over the 100%. We went all the way up to 300. So if you want to get kind of creative here, you could even kind of show this, and I think they do this in your book, as kind of a threesome bubble, just to indicate that, hey, we really grew this. Now, you wouldn't need to. A double bubble is fine, but hey, why not? It's 3 times as large. Let's go a 3 times bubble. Okay, so this is the after a bubble, and we grew it up to 300%. 300% of the original number. And the 300% was what? Well, they told us that the 300%, the what percent, which we know is 300, 300% of 30 is 90. So it is 90. All right, so there is our solution as well as our bubble. All right, very good. I think we will skip this part. I wanted you to try a couple of these on your own, but instead we'll just jump right to the assignment problems for today. So go ahead and do those, but make sure that you look back at your notebook at the diagram procedures that you wrote down there. And if you need to, come back here and just review a couple of those problems. Particularly watch out for the ones where things increase, all right? Or if they get bigger. Watch out for that. All right, excellent. We will stop there, and I will see you tomorrow.